In 2021, a group of astrobiologists at NASA proposed a scale known as the CoLD scale, which stands for Confidence of Life Detection. The need for this kind of classification is readily evident. We actually do have potential candidate detections across SETI and astrobiology. The problem is that they are ambiguous and in need of some type of classification system that defines how good they actually are. That is what the scale aims to do. To start, I should say something about the detection of alien life in general. Often people will tell me that if NASA, or more generically the government, ever found evidence of alien life, they wouldn't tell us, despite there being no reason they wouldn't. And the fact that the US government is just one national government out of nearly 200 globally, and the fact that SETI is decentralized and totally privately funded in the US, with no government oversight whatsoever. The actual fact is that the only entity to ever have announced the discovery of alien life, twice, is NASA, and both times it was called into question by the scientific community, and in many ways, NASA jumped the gun. But they had a reason. Both of the groups of detections actually were and remain unresolved and intriguing. These are the Viking Life Finder experiments, where 3 instrument packages were sent to Mars, doubled on both landers for a total of 6 instruments, and all of them returned positive results. One of the main points against this was the fact that a gas chromatograph mass spectrometer instrument detected no organics. But contrary to some incorrect information that was recently put out there on YouTube, that's been superseded by the modern Mars rovers that have detected organics to a much more updated degree and higher resolution than what could be done in the 70s. More on that in a bit. The CoLD scale goes like this. It's a 7-point scale, and in a way it's actually more of a checklist than a scale. It goes by levels, and level 1 is the detection of a signal of any sort that is a candidate for something of alien origin, whether biological or a technosignature. The scale is general in this regard in order to cover all possibilities of alien life. So step 1 here is the detection itself, which could be anything from a candidate radio signal in SETI to a fossil in a meteorite. Step 2 is simple. Rule out that it's not contamination. Step 3 is more tricky. If you want to ensure that wherever it came from, it originated in a habitable environment. For a signal of technological origin, that would be tricky, because we aren't sure exactly what a habitable environment for a highly advanced technological alien civilization would be. But for rock, it's actually happened. There, the second time NASA announced the discovery of potential alien life was in a meteorite that originated on Mars, Allen Hills 84001, and it appeared to have traces of fossil microbes. That was called into question, especially in regards to the microbes, if that's what they once were orders of magnitude smaller than anything on Earth that we know of. That wasn't a showstopper. There are some hypotheses of life actually being possible at much smaller scales, but it did question the results of that study. Anyway, that study passes number 3 because we know that Mars was once habitable, and we even have bubbles in other Mars meteorites that contain samples of the Martian atmosphere. These are volcanic rocks blasted off the surface. Like volcanic rocks on Earth, they can contain atmosphere samples. Number 4 is where it gets harder. So here it has to be shown that whatever you're studying cannot be produced by a known non-living process. This is a huge problem for exoplanet atmospheres because there actually are comparatively few gases associated with life that are solely produced by life. Oxygen is a good example here. While on Earth it's life producing the oxygen, oxygen is also very common in the universe, and you don't need life for oxygen to be in an atmosphere. Number 5 is basically to look further and wider. Especially with an exoplanet showing a suspected biosphere, you want to do whatever you can to find a separate indicator of something going on, so you're working with a profile instead of a single indicator. That gives your findings a more robust base to go on, and will help to provide a more compelling case that you have indeed found an exoplanet with a biosphere. Number 6 is to rule out any alternative hypotheses that have been presented against the detection. This is a given in science. If one hypothesis is advanced to explain an observation, there will be multiple others to try and offer alternatives that you may not have initially considered. This allows the scientific community to come to a consensus. If you can rule out the alternative hypothesis, you pass on to number 7. 7 is interesting because often the detection of something can lead to predictions that you will see other signals related to it that bolster the case. But here it's suggested that those observations can be done with different observatories and instruments to further strengthen the case that there aren't any instrument artifacts involved. As it stands right now, every candidate for alien life in the universe that we have detected has failed to move on from number 3 on the CoLD scale. It's worth noting another difference here between detecting a biosphere and detecting a technosignature. The technosignature angle can leapfrog a number of these steps simply because something of unambiguous technological origin, in other words, it's blatantly obvious, will probably take a different route of steps and go directly to devising experiments to determine anything we physically can about that alien civilization. It's possible, and this is often lost in the SETI discussion, for a signal to be so unambiguous that there simply will not be a question over it. Obvious is obvious. We have not seen that yet. To give a smattering of candidates for something going on and where they ranked on the list, the 2 Mars detections are the best. They are the ones that hit number 3. One in particular, the Viking experiments, are extremely relevant right now with the direction that human space exploration is taking. As I said, all experiments on those missions returned positives when they searched directly for life. The one objection, the organics null result, has turned out to not be the case. A new book coming out by Dr. Stephen Benner called Meet the Neighbors explores this in depth. It's not out until July, but I have read an advanced copy and recorded an interview with him for Event Horizon that will be out within a few weeks. And it's clear that a repeat of these experiments are needed before anyone sends humans to Mars, by whatever means that may be. We also need to be careful with any sample returns, because yes, while we have Mars meteorites on Earth and they haven't infected anything, they also spent conceivably millions of years in space before they got here, and may not indicate as much as is currently thought as far as the current sterility of Mars. It's likely that the experiments will be repeated in updated form if private ventures do indeed go to Mars, and probably less likely if left to governments looking to do manned Mars missions. But it needs to be established for anyone who goes there and inadvertently exposes themselves to a potential alien pathogen. It's unlikely that anything on Mars could infect a human, but it's non-zero. And there are other issues, such as the introduction of a Martian microbe inadvertently to the human gut biome, or concerns of that nature that haven't been tackled yet in how we think about this stuff. Those are the best we have, but others include detections like K2-18b, where a potential life-created gas was marginally detected, Venus, where phosphine and other hints are found, ambiguous technosignatures like Jabilsky's star, and a handful of others. But none have scored higher than the Mars detections. And Mars hints in a growing list of other ways to have been, and potentially still is, harboring microbial life of some sort. Even if Mars life isn't native to Mars and is transported Earth life, the adaptations it has gone through to survive on Mars may actually make it far more dangerous to humans than an alien microbe might be. In the future, there are some strong potentials for further detections of something. One to watch here is in the ice shelf moons. We have missions going to Jupiter already in space, and they are designed to look at icy moons like Europa, and have instrumentation capable of better characterizing those moons, and, importantly, their water and what's in it. There is also Enceladus at Saturn. In 2018, very complex organic molecules were found that basically appeared to be round molecules composed of nitrogen, oxygen, and hydrocarbons. And one of the candidates for what it could be is something like humic acid, which is linked to microbial life on Earth. This was only the discovery of a molecule of unknown nature, ultimately, and organic molecules can form in a radiation environment like space. But since the molecules come from the interior of Enceladus, it remains intriguing because that narrows the options. But even then, Europa Clipper in particular is designed to sniff out chirality, whether through flying through plumes, flying off the surface of Europa through cracks that lead to the subsurface ocean, if Europa indeed has them, or has them when it's there, or by looking at impacts where recent ice is exposed. Chirality takes you a good way in determining the potential for life. There is solid potential that these Jupiter missions might get us to 4 or higher on the scale with any luck. And there's Mars again. There are sealed sample containers sitting on the surface of Jezero crater on Mars collected by the Perseverance rover. Plans for a sample return mission are not currently on the table due to budget cuts, but any other country going to Mars might choose to pick them up, or plans in the US may change, in which returning samples of sedimentary rock to Earth directly from Mars may reveal evidence of life that could go far higher on the scale if the right things happen. Fossil evidence might not be definitive, but this includes the intriguing Cheveya Falls sample, where the rover itself found evidence of what looks like the markings of past biology in the rocks. Such markings on Earth are biological most of the time. This would at least hit a 6 on the scale, should it happen. So that is how the CoLD scale works in a nutshell, and I suspect it will become increasingly important as we explore places like Mars and Europa more deeply in the coming years, along with, of course, ongoing efforts with SETI. It will be an interesting process, indeed. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently talking about gardening again. I'm growing some things this year that I sometimes grow and sometimes don't, that aren't all that common in the United States but are in other places. One of these is borage, which tastes something like cucumber but in a leaf, and has really nice flowers when it blooms, but is somewhat toxic. And chervil, which is very popular in France. I like it with eggs. That has an anise flavor, but it has reached the end for this year as it's gotten hot out and it died. And finally, yerba mate is an experiment, a traditional plant in South America that's used for tea, just as a fun experiment. But it has been a good year so far for container gardening, as evidenced by my corn. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.